Introduction to Layer 2 solutions. Layer 2 solutions are technologies designed to scale blockchain networks, handling transactions off the main blockchain. These solutions aim to improve scalability by offloading transaction processing and data storage to separate networks, thereby reducing the load on the main chain. Scalability is a critical challenge for blockchain networks, especially as adoption and usage increase. Layer 2 solutions address this challenge by providing a framework for faster and cheaper transactions, enhancing the overall efficiency of blockchain networks. Common Layer 2 solutions include state channels, rollups, and sidechains, each with unique advantages and trade offs. So let's talk about the scalability problem. Layer 2 solutions are becoming increasingly more important as blockchain networks like Ethereum face scalability challenges. Ethereum's layer 1, while powerful, struggles to accommodate to a high volume of transactions. These limitations manifest in several ways, including high transaction fees, slow confirmation times, and limited throughput. These issues impact the usability and accessibility of blockchain technology, particularly for applications requiring frequent or high volume transactions. So, how do layer 2 solutions work? Layer 2 solutions operate by moving transaction processing and data storage off the main blockchain, essentially creating a separate layer for these operations. This off chain processing reduces the burden on the main chain, leading to faster transaction times and lower fees. After a certain period, transactions on the layer 2 network are settled on the layer 1 blockchain. This periodic settlement ensures security and data integrity, guaranteeing that all transactions are ultimately recorded on the main chain. This approach allows layer 2 solutions to achieve significant performance improvements while maintaining the security and immutability of the underlying blockchain. So let's talk about the type of layer 2 solutions. So first would be state channels, then you have side chains, rollups, and plasma. So let's go through them one by one. State channels are off-chain solutions that enable fast and cheap transactions between two parties. Participants establish a channel where they can exchange value without the need for each transaction to be broadcast on the main blockchain. Approach significantly reduces transaction costs and speeds up processing. Sidechains are separate blockchains that run in parallel to the main chain. They can be used to process transactions faster and cheaper while still maintaining a connection to the main chain. This allows for a trade off between security and performance depending on the specific needs of the application. Rollups bundle multiple transactions together and submit them to the main chain as a single transaction. This reduces the number of transactions that need to be processed on the main chain, improving scalability. There are two main types of rollups, optimistic and zero knowledge, called ZK rollups. Each has its own strength and weakness, right? So next is Plasma, which is a framework for creating scalable off-cut. It uses a Merkle tree to efficiently verify the validity of transactions without having to process them all on the main chain. Plasma offers high throughput and low transaction costs while maintaining a high level of security. State channels. State channels are a type of layer 2 solution that enables fast and cheap transactions between two parties. The parties open a channel off chain, exchanging value without needing to broadcast each transaction on the main blockchain. These transactions are only settled on the main blockchain when the channel is closed, reducing the burden on the network and lowering costs, which is our main aim. This approach is particularly beneficial for frequent transactions between two parties, such as micropayments or gaming applications. So let's go through the example code here. Right, I'll try to explain this in as much detail as I can. So here we go with the code. Again, it's a Solidity contract, right? First, you're specifying the state variables, address payable public sender. This is the address of the sender who creates and funds the payment channel. Address payable public recipient, address of recipient who will receive the funds. UN 256 public expiration, the timestamp at which the payment channel expires. So next you have your constructor, right? The constructor is called when the contract is deployed. It initializes the sender, recipient, and expiration variables. The sender is set to the address deploying the contract. Recipient is set to the specified recipient address. Expiration is set to the current time plus the specified duration. Constructor is also marked as payable to allow the contract to receive Ether upon creation. Okay. Next, we have our close function. So, this function allows the recipient to close the payment channel and claim the specific amount. So, it ensures the caller is the recipient. It verifies the signature provided using the verify function. Then it transfers the specified amount to the recipient. And finally, at the end, it destroys the contract and sends any remaining balance to the sender. Okay, so let's go to the next page. Right now, you have your verify function. So, this function verifies the validity of the signature. It hashes the amount using KCAC 256. Then it prefixes the hash to conform to the Ethereum signed message format. After that, it recovers the signer's address from the message and signature. And finally, it compares the recovered address with the expected signer's address. Okay, next you have your prefixed function. So this function prefixes the hash to conform to the Ethereum signed message format, which helps in verifying the message was signed by the intended signer. Next is your recover signer function. So this splits the signature into V, R, and S function to recover the address from the message and signature content. Finally, you have the split signature function. So as I mentioned, this function splits the signature into V, R, and S components using inline assembly. So we are using inline assembly here. Next, you have your reclaim function. This function allows the sender to reclaim the funds if the payment channel has expired. It ensures that the current time is past the expiration time. And finally, it destroys the contract and sends any remaining balance back to the sender. Okay, so now let's talk about sidechains. Sidechains are separate blockchains that operate in parallel to the main blockchain. Chains can interact with the main blockchain, enabling cross-chain communication and functionality. This allows for a trade-off between security and performance, where the sidechain can offer faster and cheaper transactions. Sidechains are independent blockchains with their own consensus mechanism and tokenomics. They can offer specialized features or functionalities that are not available on the main chain. For example, XDAI is a sidechain built on the Ethereum network, enabling faster and cheaper transactions while still maintaining compatibility with Ethereum. Okay, so rollups. Rollups are a type of layer 2 solution that can process transactions off chain and submit a compressed record of these transactions to the main chain. Approach enables faster and cheaper transactions while maintaining the security and immutability of the underlying blockchain. So we'll talk about optimistic rollups and ZK. Optimistic rollups. What are optimistic rollups? These rollups assume transactions are valid unless proven otherwise. Fraudulent transaction is detected, a challenge period is initiated where anyone can contest the validity of the transaction. Next are ZK or zero knowledge rollups. These rollups use cryptographic proofs to demonstrate the validity of transactions without revealing the underlying data. Provides a high level of security and privacy as it prevents anyone from observing the specific details of transactions. Both optimistic and ZK rollups offer significant improvements in scalability and efficiency compared to traditional on chain processing. The choice between these two approaches depends on the specific needs and priorities of the application, such as the required level of security, privacy, and transaction speed. So let's go to optimistic rollups in detail, right? So these operate on the assumption that all transactions are valid, like I told. They provide a mechanism for disputing transactions known as a challenge period. This period allows anyone to challenge the validity of a transaction by providing proof that it was fraudulent. If the challenge is successful, the transaction is reverted, ensuring the integrity of the network. Optimistic rollups are known for their high throughput and cost efficiency, ability to process transactions in batches, and only commit valid ones to the main chain results in significant improvements in scalability and cost reduction. They're a popular choice for developers building decentralized applications or dApps that require high transaction volume and affordability. However, it is important to note that the challenge period introduces a delay in transaction finality, as disputes need to be resolved before the transaction is considered permanent. So let's talk about ZK or zero knowledge rollups. So ZK rollups leverage zero knowledge proofs to verify transaction validity without exposing the underlying data. These proofs offer a level of privacy as they don't reveal the specific details of transactions. ZK rollups are highly efficient and offer near instant finality, meaning transactions are confirmed quickly and permanently. However, ZK rollups face challenges related to computational complexity. The generation and verification of zero knowledge proofs can be computationally demanding, requiring significant resources and specialized hardware. This limitation is being addressed through ongoing research and development, with advancements in cryptography and hardware improving the efficiency of ZK rollups. Let's talk about plasma. Chains, also known as plasma chains, are a type of layer 2 solution that operates as a separate blockchain. Smaller blockchain periodically submits snapshots of its state to the main Ethereum chain. This approach provides a high level of scalability while maintaining a connection to the main chain security. Plasma chains offer significant advantages in terms of transaction speed and cost efficiency. They are particularly well suited for applications that require high throughput, such as decentralized exchanges or gaming platforms. However, plasma chains present unique security challenges. If the plasma chain is compromised, it could potentially lead to the loss of funds on the main chain itself. So let's talk about advantages of different layer 2 solutions we have discussed. The first is lower transaction fees. These solutions offer a significant advantage in reducing transaction costs. By offloading processes to a separate network, they alleviate the burden on the main chain, leading to lower fees. This cost reduction makes blockchain technology more accessible and affordable for a wide range of applications. This faster transaction times, so these significantly improve transaction speed. They achieve this by processing transactions off chain, enabling faster confirmations and reduced latency. This increased speed is crucial for applications requiring real time interactions and instant settlement, such as decentralized finance and gaming. Next is improved scalability. Layer 2 solutions address the inherent scalability limitations of blockchain networks. By reducing the load on the main chain, they enable the processing of a larger volume of transactions without compromising performance. This enhanced scalability opens up possibilities for broader adoption and more complex applications. Let's talk about challenges of layer 2 solutions too, right? First are your security concerns. So, layer 2 solutions must maintain security despite being off chain. They rely on bridges to connect to the main chain, which introduces new attack vectors. Security audits and robust security measures are essential to mitigate these risks. Next are user experience issues. So, layer 2 solutions often require users to interact with different interfaces, potentially confusing them. Simplifying user experience is crucial for mass adoption, especially for those unfamiliar with advanced blockchain concepts. Next is interoperability with layer 1. So interoperability between layer 2 solutions and layer 1 solutions is crucial. Seamless communication and value transfer across different chains are essential for a cohesive ecosystem. This ensures users can easily move assets and interact with different applications. So, Layer 2 and Ethereum 2.0. Layer 2 solutions and Ethereum 2.0 are complementary technologies, both striving to improve Ethereum scalability. While Layer 2 focuses on off chain processing, Ethereum 2.0 addresses on chain limitations through sharding, a technique that divides the blockchain into smaller parallel shards. These technologies synergize, creating a more robust and scalable ecosystem. Layer 2 solutions can benefit from Ethereum 2.0's increased throughput and sharding's enhanced security, ultimately leading to a more efficient and user-friendly experience. Let's talk about some real-world examples of Layer 2 solutions. First is Arbitrum. Arbitrum is an optimistic roll-up solution that provides a scalable and secure environment for decentralized application. It prioritizes user experience, offering fast and affordable transactions. Arbitrum's Layer 2 network is designed to be compatible with existing Ethereum applications, enabling seamless migration and integration. Next is Polygon, which is formerly known as Matic. So, Polygon is a layer 2 scaling solution that provides a framework for building and deploying various types of scalable blockchain. It offers a range of solutions, including optimistic rollups, ZK rollups, and sidechain. Polygon aims to enhance the usability and scalability of Ethereum through its diverse range of technologies. This is Loopring. Loopring is a layer 2 scaling solution built on ZK rollups, enables efficient and private off-chain trading for decentralized exchanges DEXs. Loopring zero knowledge proofs allow users to exchange assets without revealing their trading information, enhancing privacy while maintaining security and scalability. So the example we are going to talk about now is Arbitrum. Arbitrum is a pro Arbitrum is a popular layer 2 scaling solution that employs an optimistic roll-up approach to enhance Ethereum scalability. This solution allows for a higher transaction throughput and lower fees compared to traditional on-chain transactions. Arbitrum's design ensures seamless integration with Ethereum, facilitating the easy migration of existing applications and the development of new ones. Arbitrum's optimistic roll-up mechanism assumes the validity of transactions unless proven otherwise. If a fraudulent transaction is identified, a challenge period is initiated, allowing anyone to dispute the transaction. This approach provides a balance between speed and security. By offloading transaction process to a separate network, Arbitrum alleviates the burden on the Ethereum main chain, leading to significant improvements in scalability and efficiency. Next is Polygon. So, Polygon, which was formerly known as Matic Network, offers a multi chain approach to layer 2 scaling. It provides a framework for developing and deploying various types of scalable blockchains. So, Polygon supports both sidechains and rollups, enabling users to choose for the most suitable solution for their specific needs. Polygon prioritizes interoperability with Ethereum, allowing seamless integration with the Ethereum ecosystem. This ensures that applications built on Polygon can easily interact with existing Ethereum infrastructure and applications. Polygon's versatility makes it suitable for a wide range of use cases, from decentralized finance and gaming to non fungible tokens, NFTs, and decentralized exchanges, DEXs. Finally, let's talk about the loopring example. So what loopring does is it leverages ZK rollups, zero knowledge rollups, to create a high performance layer 2 scaling solution for decentralized exchanges. This technology allows for rapid transaction processing, minimizing delays and improving the user experience. Loopring prioritizes efficiency and affordability, offering low transaction fees, making it a cost effective option for traders. Loopring is designed with privacy in mind. Its ZK rollups enable users to conduct trades without revealing their trading activity, protecting their anonymity and data security. Let's talk about the future of layer 2 solutions. So, first is increasing adoption, right? So, layer 2 solutions are becoming increasingly popular. More developers are building on layer 2 networks. This increased adoption will lead to a more robust and diverse ecosystem. Next is enhanced security measures. The security of layer 2 solutions is paramount, right? Researchers are constantly developing new security measures. These measures will improve the overall security of the entire Ethereum blockchain. Finally, integration with other blockchain technologies. So, layer 2 solutions are becoming more and more interoperable. They will be able to seamlessly connect with other blockchains. This interoperability will enable more complex and innovative applications. So let's talk about building on layer 2 development frameworks. Building on layer 2 solutions requires specialized development frameworks. These frameworks provide tools and libraries to simplify the process of creating decentralized applications. Examples include Arbitrum's SDK, Polygon's developer documentation, and Loopring's SDK, each tailored for its specific layer 2 network. So, best practices, several best practices for developing on layer 2 are critical for security and efficiency. These include thorough security audits, optimizing code for gas efficiency, and understanding the specific limitations of each layer 2 network. Following these best practices ensures a secure and robust application. Finally, example projects. Many successful projects have already built on layer 2 solutions. Uniswap, a leading decentralized exchange, has deployed Arbitrum for enhanced scalability. Aave, a lending protocol, has implemented on Polygon to reduce gas fees and improve user experience. These projects demonstrate the potential of Layer 2 for building innovative and scalable applications. Finally, conclusion and next steps solutions are essential for enabling Ethereum scalability. By offloading transaction processing to separate networks, they improve the user experience, reduce transaction fees, and enhance the overall performance of the Ethereum ecosystem. We encourage you to explore these solutions, experiment with different layer 2 networks, and stay updated on the latest advancements. This will allow you to build innovative and scalable decentralized applications that benefit from the advantages of layer 2 technologies. Thank you, and I'll see you in the next video.